At the forefront of our solar system lies Mercury, a small, uninhabited planet shrouded in intrigue and mystery. Initially, nothing seemed remarkable about this planet, but recent investigations by NASA have unveiled surprising discoveries that have sparked significant debate within the scientific community. Some researchers now speculate about the possibility of extraterrestrial life hiding on this enigmatic planet, fueled by the tumultuous findings and various conspiracy theories that have emerged. In contrast, a more mainstream perspective among established scientists is taking shape, a systematic effort to strip away the confusing layers surrounding Mercury and uncover its dark secrets. What astonishing truths have scientists revealed about Mercury? And what groundbreaking plans does the academic community have for this cosmic neighbor? Join us in this video as the James Webb Telescope finally uncovers what NASA has been concealing about Mercury. Our solar system is more than just a collection of planets revolving in a vast cosmic dance. Each of the 8 planets in this intriguing ring system possesses unique characteristics. While planets like Jupiter and Mars often grab the spotlight due to their remarkable features, another fascinating celestial body that frequently goes unnoticed is Mercury. Positioned closest to the Sun, Mercury is only 58 million kilometers away, in stark contrast to Earth's 150 million kilometers. This small planet is also significantly smaller than Earth, measuring just 3,000 kilometers in diameter. Due to its proximity to the Sun, Mercury orbits at an incredible speed of 47 kilometers per second, completing a full rotation in just 59 Earth days. Consequently, 1 year on Mercury lasts only 88 Earth days. Mercury's small size and rapid orbit are merely a few of its intriguing traits. From a distance, this seemingly inconspicuous planet has always captivated scientists. However, it has not received as much attention as its more prominent neighbors for reasons that remain unclear. The first documented observation of Mercury dates back to 265 BC, with early astronomers such as Hipparchus noting its presence. However, scientists of that era had limited knowledge due to their reliance on rudimentary scientific equipment and primitive telescopes. It wasn't until the 1960s that substantial information about Mercury began to surface, largely thanks to NASA's initiatives. A few years ago, NASA released the first genuine images of Mercury to the public, showcasing the planet as a stunning and complex entity. However, this achievement came at a considerable cost. Despite years of planning and dedicated efforts to study Mercury, scientists were able to get only a fleeting glimpse of it. Observing Mercury is particularly challenging due to its proximity to the Sun, as the intense rays and bright light can damage optical instruments like telescopes if they focus on the planet for too long. Consequently, researchers can observe this tiny planet for only short periods to prevent equipment damage. Even the James Webb Telescope cannot point directly at Mercury due to its closeness to the Sun. It's frustrating that this relatively small neighbor is more difficult to study than the more distant planets, all because of the Sun's heat and gravitational pull. Sending a probe to Mercury is akin to a suicide mission rather than a scientific expedition, as the spacecraft must endure extreme temperatures, atmospheric conditions, and gravitational forces or risk being destroyed. You may be surprised to learn that Mercury travels around the Sun at an impressive speed of 30 kilometers per second. This rapid pace makes it the fastest orbiting planet in our solar system, presenting additional challenges for any spacecraft intending to study or land on its surface. To date, only 2 missions have targeted Mercury. Mariner 10, launched on November 3, 1973, and Messenger, which took off on August 3, 2004. Both missions were conducted by NASA and are the primary sources of the information we currently have about Mercury. The Mariner 10 spacecraft performed 3 flybys, revealing Mercury's cratered surface and providing insights into its magnetic field. Equipped with 2 telescopes, spectrometers, a magnetometer, and a plasma analyzer, Mariner 10 aimed to gather as much data as possible from its visit to Mercury. As the spacecraft drew closer to the small, fast-moving planet, researchers were astonished to see its chaotic, cratered landscape reminiscent of our Moon. The images sent back by Mariner 10 were breathtaking, portraying Mercury as a far more complex world than scientists had anticipated. In addition to its rugged surface, the spacecraft detected a weak magnetic field and an unexpectedly large core. Over the course of its mission, Mariner 10 captured 2,700 images of Mercury, providing researchers with a fascinating and unparalleled view of its unique terrain. The second flyby of Mariner 10 occurred on September 21, 1974, capturing images of the planet's southern polar region, while the final flyby took place in March 1975, after which the spacecraft ceased communications with Earth. Subsequent analyses revealed that Mariner 10 had run out of fuel and could no longer continue its mission. The remarkable achievements of Mariner 10 were followed 30 years later by NASA's Messenger mission, which aimed to study the nearby planet in greater detail. Unlike its predecessor, Messenger not only performed flybys but also entered orbit around Mercury. This enabled researchers to gather more in-depth and intriguing data about the planet. Equipped with sophisticated imaging capabilities, NASA sought to investigate Mercury's environmental conditions and chemical composition further. The agency also aimed to study the planet's magnetic field and explore its geological history and planetary core. True to expectations, Messenger completed 3 orbits around Mercury, capturing around 200,000 photographs of the planet. These images were particularly valuable as they encompassed both the light and dark sides of Mercury, providing insights into its surface and composition. By analyzing these photographs and comparing them with data collected by the spacecraft's instruments, NASA discovered surprisingly high concentrations of calcium and magnesium on the planet's night side. Additionally, Mercury's magnetic field appeared unusually distorted, with greater intensity in the northern regions. This peculiar magnetic field pattern puzzled scientists for years until further research and analysis revealed its underlying cause. Mercury's unique magnetic field is attributed to its formation process. Unlike Earth, where the core consists of liquid iron that solidifies toward the outer core, Mercury's internal structure produces a magnetic field through different mechanisms. The distinct characteristics of Mercury's magnetic field continue to intrigue scientists and open new avenues for ongoing research led by scientists at the University of California, Los Angeles, has revealed that iron transitions from liquid to solid at the outer edge of Mercury's core, which differs significantly from Earth's core behavior. Lead researcher Ho explained that while we had previously understood how Earth operates, Mercury, another terrestrial rocky planet with an iron core, behaves differently than expected. It's akin to a snowstorm, where snow forms at the top of clouds and the lower parts. Our examination of Mercury's magnetic field suggests that iron is snowing throughout this liquid layer, which powers the planet's magnetic field. Further studies confirmed that these findings align with data from NASA's Messenger mission. This discovery has led researchers to consider that planets may have various methods of generating magnetic fields. Despite Mercury and Earth sharing similar core components, such as sulfur and iron, the differences between the two planets can result in striking variations in their magnetic fields. The discrepancies between Earth and Mercury extend beyond their magnetic characteristics. For instance, temperatures on Mercury can soar above 430 degrees Celsius during the day but plummet to as low as -170 degrees Celsius at night. This drastic temperature fluctuation is attributed to Mercury's lack of a substantial atmosphere. Unlike Earth, Mercury possesses a thin exosphere composed mainly of particles ejected from its surface by meteoroid impacts and solar winds. Scientists believe the intense heat on Mercury causes any potential atmospheric formation to quickly dissipate into space. Consequently, the side of Mercury facing the Sun endures extreme heat, while the opposite side remains in darkness. Here's a fascinating fact. One complete day on Mercury actually lasts twice as long as its year. While a year on Mercury takes about 88 Earth days, a single day lasts 176 Earth days. This means one hemisphere of Mercury is continuously exposed to extreme heat and sunlight, while the other side remains perpetually dark. These two factors, the absence of a substantial atmosphere and prolonged sunlight, contribute to the extreme temperature variations on the planet. The harsh temperatures on Mercury have sparked ongoing debate within the scientific community. Although its magnetic field and rocky soil structure suggest potential habitability, the extreme temperatures make life on Mercury virtually impossible. Nonetheless, some intriguing aspects of this enigmatic planet have raised questions about the possibility of discovering organic life there. This has led to speculations about whether Mercury could indeed be habitable and, if so, what forms of life might exist. So far, the surface of Mercury has proven to be quite intriguing, resembling our Moon with its numerous impact craters. The Moon has long been associated with theories and conspiracies about extraterrestrial life due to its vast number of craters, some of which have unusual shapes. While there is no concrete evidence of alien moon bases, similar possibilities have begun to be entertained regarding Mercury. Although impact craters are typically caused by asteroids, it is certainly conceivable that some may result from spacecraft. For instance, NASA's Messenger probe created a significant crater upon impacting Mercury's surface on April 30, 2015. Currently, Mercury's surface showcases a variety of craters, fissures, cliffs, and even signs of volcanic activity. What if some of these craters were created by extraterrestrial craft or activities? Additional surprising facts about Mercury have also fueled conspiracy theories, such as the ice water deposits discovered in the bottoms of craters at the planet's poles. A recent study from the Planetary Exploration Foundation revealed that conditions at Mercury's North Pole may be suitable for extreme forms of life. These potentially habitable areas exhibit conditions reminiscent of Earth, albeit hidden beneath the planet's surface. This remarkable conclusion was drawn from analyzing images captured by NASA's Messenger mission, which were used to create detailed maps. Using this data, researchers identified salt glaciers on Mercury that contain volatile compounds, bolstering the possibility of organic life. Despite the harsh conditions and the planet's proximity to the Sun, scientists believe that extraterrestrial life or some form of biological existence could be possible on Mercury if we dig deep enough. One of NASA's Messenger mission's significant achievements was creating a detailed map of Mercury, marking all the craters and basins on its surface, allowing for in-depth studies of the planet's geology. The probe also uncovered Mercury's surface composition: 43.6% oxygen, 12% magnesium, 26% silicon, 7% aluminum, and 4% calcium. Researchers also detected an unusually high abundance of volatile elements, like sulfur, alongside surprisingly low levels of iron. This finding sparked discussions within the scientific community, as it distinguished Mercury from other planets in the solar system, which typically have higher iron and sulfur contents in their metallic compositions. The discovery of a curious dusty ring around Mercury has also raised eyebrows. This finding has sparked debate, as many experts question how such a small planet could possess a planetary ring. In our solar system, only Jupiter and Saturn are known for their rings. Jupiter's rings are faint and were first observed by the Voyager 1 spacecraft in 1979, while Saturn's ring system is well-defined and visible even from Earth. Saturn's rings comprise billions of small particles, some quite large, orbiting the Sun. The materials in Saturn's extensive ring system include water ice and rocky materials. Researchers believe that the rings of Saturn and Jupiter formed during the early stages of our solar system, with the planet's massive sizes playing a crucial role. Saturn is over 9 times the diameter of Earth and attracted a vast amount of tiny rocks and particles, forming its ring system. Jupiter, nearly 11 times the width of Earth, has captured around 95 moons and developed its own miniature ring system. Given the immense sizes of Saturn and Jupiter compared to Earth, it is understandable how these giant planets could attract astronomical debris and particles with their strong gravitational pull. However, this raises questions about how Mercury, a much smaller planet, has developed a dusty ring. Researchers using data from NASA's Messenger mission discovered salt glaciers on Mercury filled with volatile compounds, suggesting the potential for organic life despite the harsh conditions. The probe also mapped Mercury's surface, revealing its distinct composition: 46% oxygen, 12% magnesium, 26% silicon, 7% aluminum, and 4% calcium, along with high sulfur and low iron levels. This surprising finding has generated debate, and Mercury's dusty ring remains enigmatic, with theories suggesting that meteorite impacts might have contributed to its formation. Despite its thin mantle and unusual structure, Mercury's mysteries continue to invite further exploration. The upcoming Bepi Colombo mission aims to unveil more secrets upon its arrival in 2025, highlighting Mercury's increasing significance in space exploration.